Okay, so next on the list is problems asked for use a list of equations and inductive reasoning to predict the next number and then verify your conjecture. So let's look at problem 31. I'm not going to rewrite the whole thing, but if you look at your book, the first entry is 9 times 9 plus 7 is equal to 88. So we have 81 plus 7 is 88. And if you keep going down, you'll get down to the fourth entry, which is 9876 times 9 plus 4 is equal to 88,888. And there were all the ones in between. This went 6 and 5, and this went, actually I ended up writing the whole thing, so you have 98, and then you have 987, then you have 9876. So you can see the pattern. And this whole idea of recognizing patterns, if you ever take an IQ test, you'll notice that half of it's verbal and half of it's math. And the math part is basically recognizing patterns. If you're good at recognizing patterns, you're good at math in general. So that's what we're doing here. We're recognizing patterns. So if we have 9, 98, 987, 976, so the next one logically would be 98765 times 9 plus 3, because we're decreasing this one by one at a time. And we would, so we're inducing what the next, using inductive reasoning based on the past experience, what the next value on the left-hand side. And you can also induce using inductive reasoning to figure out what the value on the right-hand side, which it would be all 8s, except we have one more 8. So we'd have 888,888. So that, and it's kind of neat about number sequences, how you can come up with interesting conclusions that you wouldn't necessarily think. Okay, so number 35 is we have 34 times 34 is equal to 1156. The next would be 334 times 334, and that's equal to 111566. Okay, so now if we tried to do using deductive reasoning, the first thing we would do is we could probably add another 3 to the beginning. So it would be 3334. And the question is, what would you expect here? Would I add another 1, 2 1s, would I add a 6 on the end, would I add 5? So it's not obvious at this point what the next thing is. But if you calculate it, the actual result is 111556. So what did we do here? We went from 2 1s to 3 1s to 4 1s. I must have written something wrong here. Yeah, I did this wrong. So this is 5, 6. And so this went from 3 to 4, this went from 2 to 3, but this still stayed just 1. So the pattern, what I would think is, okay, I'm going to add another 3 to the end here. So we have 3, 3, 3, 3, 4 times 3, 3, 3, 3, 4. So I'm increasing the number of 3's from 3 to 4. On the left-hand side, I'm going to increase this from 4 to 5. So I'd have 1, 1, 1, 1, 1. I would increase this. This was from 1 to 2 to 3, so that I'd have 4 of those, 5, 5, 5, 5, 5, and I have 1 6 on the end. And if you want to multiply that out with your calculator, you'll find that this is the next term in the sequence. Okay, let's look at number 39. So we have 5 times 6 is equal to 6 times 6 minus 1. So that's the first term. We have 5 times 6 plus 5 times 36 is equal to 6 times 36 minus 1. Anyway, I'm just trying to figure out why it was this way, but we really don't know. We need to know why it is at this particular point. We just have to recognize a pattern. Okay, so let's look for patterns. We're adding a term on the left-hand side. This number is that number times 6, or it's also squared. Here we're taking the largest number and we're subtracting 1 from that. And then this is 1 more than 5. So the question is, is the next one 36 squared or is it 36 times 6? That's probably the question. And if you take 6 times 36, you can see it's 216. So the next term will be this times, we add one more term, 5 times 6 times 36, which is 216. We use the largest number, 216, subtract 1, multiply that result times 6. So now we've got one more step just to make sure we see the pattern. We keep all the previous terms. We add one term, which is 5 times 6 times 216. 6 times 216 is 1296. Take the largest number, 1296, subtract 1, multiply it by 6. So at this point, I feel pretty confident that the way we would do this is we would write all the previous terms on the left-hand side. And then I would multiply this by 6. So I'd have 5 times 1296 times 6. I'll use my calculator for that. 1296 times 6 is 7,776. All these are multiplied by 6. I'm use the largest number, 1,776 minus 1. And they don't actually give this in the book, but I'm 99% sure that's correct. And one more problem fits, well, actually it would be into 43. So we'll just leave, we'll stop right there.